Hello viewers, welcome back to my channel. Today's topic of discussion is on another network device called as bridge. So in my previous video sessions, I have explained you about hub and repeater. The next in the list is bridge. This bridge operates on the data link layer. That is, the bottommost layer is physical layer. The next one is the data link layer in the OSI model. It connects one LAN with the other LAN. It divides the network into parts. The networks connected should be using the same protocols. It uses the MAC address to forward the data. So these points I'll just explain you with the diagram, and you have to definitely first know or recall the functioning of the hub, which I have explained in one of my previous video session. This was the diagram, and what is the function of the hub? It is required here for you to understand the functioning of the bridge. Suppose if this PC1 wants to send the message to PC6, let us assume, then instead of sending only to, that means this hub, when it receives from PC1, instead of forwarding or sending only to PC6, it used to send to all the devices, and we have observed that because of this definitely bandwidth consumption is more. Now we can just try to come out with a solution for this kind of problem, wherein what we can do is, see, look at this sentence, divide the network into parts. Now let us take, this was the original network. If I have to divide into parts, now I'll just divide this network into two parts. So what I am doing is, I have a hub here with 4 ports. I have another hub with 4 ports. Fine. And for this port also we have the different PCs connected. Okay. So here on the other side, that is for the second hub also, let me show the different PCs connected. So let us number this: PC1, PC2, PC3, PC4, PC5, PC6, PC7, PC8. So now what we are doing here is, we will use another device called as bridge, which connects these two networks or these two LANs. Here is one LAN, here is another LAN, here is one local area network, here is another local area network, and connecting these two LANs is what a device called as bridge. The networks connected should be using the same protocols. Original network is there, definitely it has to use the same protocols. The original network itself is getting divided into two parts here. So here I am just taking two parts because I assume here the bridge is having only 2 ports. Port number 1 let me write here, and port number 2 let me write on the other side. To port 1 is connected 4 PCs, to port 2 is connected another 4 PCs. So this part and this part, the whatever LAN is here and whatever LAN is here, these LANs will be using the the same protocols. It uses MAC address to forward the data. Now the hub, what was happening is, the hub was forwarding that packet to all the devices that it is connected with. So it was a broadcast. Now here what happens is, suppose same thing will do. PC1 wants to send a message to PC4. PC1 is connected to port 1. Okay, here is PC1. PC4 is also at the port 1 only. So when this PC1 sends a packet for PC4 and the bridge receives the packet, it will find out whether this destination host is present on this side of the network. That means, is it connected to port 1 or is it connected to port 2? So in that manner we can say that bridge can identify the devices with the MAC address. The MAC addresses of all the PCs, PC3, PC4, PC5, PC6, PC7, PC8. So this way it is maintaining the table. PC1 is connected to port 1, PC2 is connected to port 1, PC3, PC4, whereas PC5, PC6 and PC7, PC8, all these are connected to port 2. Let me write the column headings: the MAC addresses of all these PCs and the port number to which these PCs are connected. These two are the column headings for this table. It uses the MAC address to forward the data. PC1 sending to PC4 the packet is going to refer the MAC address, and it will decide, yes, this particular PC is in this part of this network itself, so no need to forward. See, if you remember, the hub was simply sending the message to all the devices. In this case, it will send that particular packet towards this link only. So towards this link means this is the hub. What hub will do? Hub has got its own functionality. It will do the broadcast. So once though PC1 is sending to PC4, it will try to forward it to PC2, PC3, PC4. If PC1 wants to send a message to PC8, PC8, that is the destination host, is present where? It is present in, it is connected to port 2. So it will forward the packet here. Now it will forward this packet towards the other side of the bridge. When the bridge sends the packet to this, the other side is what? The other side is another hub to which is connected PC8. So even here also this hub will try to broadcast this packet. Actually the recipient is intended recipient is PC8 only. The message is getting received by all the PCs that are connected to this network. In hub, all the 8 devices were receiving the message. Bandwidth consumption is more. Here at least because of bridge, what we are doing is, though this hub forwards the packet or broadcasts the packet to all the PCs that are connected, but still consumption of bandwidth will be less compared to the previous if you are dividing the network into parts. So, and once it divides, the bandwidth consumption also gets reduced because not all the devices are there at one side. The network is divided into parts, no? So that's why the number of devices that are connected to hub becomes less. The bandwidth consumption also becomes less here. So hope the explanation for this bridge is clear to you all. If you find this session useful, please like, share and subscribe to my channel. Thank you. Bye bye. Take care.